This is Math 2, 11.3a notes. That's Math 2, Unit 11, Lesson 3a. And the title is Imaginary and Complex Numbers. Imaginary and complex numbers. Okay, in the past being even up just to our previous lesson, when I've given you something like this, the square root of -4, and asked you to simplify, we would have said no real solution. Because we said we cannot take the square root of a number, which we cannot using real numbers, but you can using imaginary numbers, which is what we're working with today. Okay, so that was in the past. Now in the present, we're going to be using imaginary numbers. How do imaginary numbers work? Well, like so. Okay, first off, the square root of -1 equals I. All day, every day, that's the definition. Square root of -1, from now on, we're going to call I being the imaginary number. Square root of -1 is I. There is a 1 there. We don't say it 1I, but it is a 1I. Okay, so that means the square root of -36 would equal 6I. Because 36 is a perfect squared, square root of 36 is 6, the square root of the -1 is I, so it's 6I. The square root of -7, since 7 is not a perfect squared, the I comes out and the 7 stays in the radical, so I root 7. Square root of $-25 would be 5I, because 25 is a perfect squared. The square root of -8, 8 is not a perfect squared, but it does have factors that can possibly come out. I have 2, 2, and 2. So a 2 comes out and a 2 stays in, and the I comes out with the 2's. So it's 2I root, and then that 2 stays inside the radical. 2I because of that negative sign and that pair, and then the 2 stays in. So 2I root 2. Now technically, mathematically correct would be 2 root 2I. I like writing it this way in class with you guys because many times kids extend that too much and it looks like it's over the I, and it should not be. So this is the mathematically correct way. This is the way I'm going to write it in class, but when you see it this way on multiple choice questions, test questions, and answers, know they are the same thing. Okay, we are going to rewrite using the imaginary number I. Rewrite using the imaginary number I. Number 1, square root of -49. That's easy. 49 is a perfect squared. It's 7. So since there's a negative, it's just simply going to be 7I. That's it. Number 2, square root of -11. 11 is not a perfect squared, and it does not break down. So just the I comes out and the 11 stays in. I root 11. Okay, number 3, square root of -24. The I is going to come out, but 24 is not a perfect squared, but it does have some factors. 6 and 4, or 12 and 2, or 3 and 8, your choice. 2 and 2. 3 and 2, I have 2, 2, 2, and a 3. And this 2 is coming out. That 2 times 3 is staying in, but that 2 that's coming out is coming out with the negative sign, so 2I root 6 is staying in. 2I root 6, or 2 root 6I. All right, next piece we're going to talk about what is a complex number. Okay, a complex number is a number that looks like this: A plus BI. Now that could be a minus, A plus BI, A minus BI, the sign, or it could be -A plus BI, it doesn't matter. I'm going to put a little note here where A and B are real numbers. Okay, so we are going to find the sum or difference I'm just going to put find the sum that includes the difference because it could be a minus sign. I'll just put or difference. Okay. Number 4, parentheses 7 minus 2i plus parentheses negative 3 plus I. Okay, so can you see where I have two complex numbers? There's my first complex number, a plus bi. A is 7, b is negative 2. There's my second complex number, negative 3 plus I. A is negative 3, b is 1. Okay, we've seen these before with square roots. It works exactly the same. First off, because there's a plus sign, this is not a double distribution problem. It is not a double distribution problem. This is the one where you look to see if there's anything to distribute. If there's not, drop your parentheses. 7 minus 2i plus negative 3 plus 1i, and combine like terms. Remember, the real number comes first, or the non-imaginary number comes first. 7 plus negative 3 is 4. Negative 2i and positive 1i is negative 1i, so 4 minus I is your final answer. That's your complex number. Number 5, 1 plus 5i minus parentheses 3 minus 2i. And again, because there's a minus sign in between, it is not a multiplication, it is not a double distribution problem. Okay, so on this one, we do have a negative to distribute, and after you distribute the negative, then you drop the parentheses like I did on number 4. So 1 plus 5i minus 3 plus 2i, because a negative times a negative is a positive. Okay, combine our non-imaginary piece first. 1 plus negative 3 is negative 2. 5i and positive 2i is positive 7i. There is your complex number answer, negative 2 plus 7i. Okay, now these were not multiplication problems. This was just addition and subtraction, but we will eventually have multiplication. That's going to be our next section here. We are going to multiply. Okay, number 6. 5i times 3i. Now this is multiplication. So 5i times 3i, 5 times 3 is 15. I times I is I squared, because remember x times x is x squared. Well, i's work the same way. Add the exponents. I times I is I squared. We are not done, because we're going to put right here in this bubble, very important piece of information that you will use not only in this class, but in Math 3, Advanced Math, Calculus, and it is what I squared equals. So before we do, remember the definition that I equals the square root of negative 1. Well, if I want to find I squared, then I would square both sides so that I have I squared. I squared would then equal, inverse operations undo each other, negative 1. This right here is what you need to remember. I squared equals negative 1. Always. I squared equals negative 1. You need to know that. So I have 15 times I squared is negative 1. 15 times negative 1 is negative 15 is my final answer. All right, let's try another one. Number 7. 7i times negative 2i. Multiply the 7 times negative 2. You get negative 14. I times I, add your exponent, is I squared. So you have negative 14 times I squared is always negative 1. So you have negative 14 times negative 1, which is positive 14. All right, let's try another one. Number 3. 2 plus 3i times 4 plus 5i. Now this one is in parentheses like our the problems were on the first page. And there is no addition or subtraction, which means it is multiplication, which means it is a double distribution. We've done double distribution before. Those of you that like the window method, you can do the window method instead. Okay, so let's multiply. 2 times 4 is 8. 2 times positive 5i is 10i. Double distribution, just like we've done in the past. Okay, 3i times 4 is 12i. 3i times 5i is positive 15i squared. Okay, do you see how that worked? 8, 10i, 12i, and then 3i and 5i is 15i squared. Okay, I have like terms right there, just like we've had in the past. 8 plus 10i plus 12i is 22i. Now remember, we never leave I squared as I squared. You will have answers that have I in your final answer. I'm going to flip it over really quick. Like you see how there's an I in that answer, there's an I in that answer, there's an I in all three of these answers. It's okay to have I as an answer, but you will never have I squared in your answer, and that's because I squared is -1. So right here I'm going to have 15 times -1. That's positive 15 times -1, which is -15. 15 I squared is -1. -1 times positive 15 is -15. And I have like terms again. 8 and -15. -7 plus 22i. We have our complex number again. All right. We will do more of those in class. Number 9. 5i times 2i times 7i. 5i times 2i times 7i. 5 times 2 is 10. 10 times 2 is 7. I times I times I is I cubed. What the heck is I cubed? Like, we know I squared is -1. What does I cubed equal? Okay. Here's how I think of it. I cubed is I times I times I, and I'm going to break those two together because that is I squared, and I know what I squared is. I squared times I is indeed I to the third. Add your exponents. 2 plus 1 is 3. I squared is -1 times I is going to stay I, and I've said already it's okay to have an I in your answer, and so -1 times I is -I. All right, so you will need to know from now on that I cubed is -I. Just like you learned and should have memorized that I squared is -1, you should know eventually and have memorized that I cubed is -I. So I have 7 times -I, 7 times -1i is -7i. Okay, we will do a number 10 in class, and we will find a pattern for the I squared, I cubed, I to the fourth, that kind of stuff that you will need to know for the test. Okay, that is it for this lesson.